Lesson: Securing AI models against attacks. Securing AI models against attacks is a critical aspect of AI security and privacy, particularly as these technologies become more integrated into various sectors. The importance of securing AI models cannot be overstated, given the potential consequences of adversarial attacks, which can lead to compromised data integrity, financial losses, and erosion of public trust. This lesson provides actionable insights, practical tools, frameworks, and step-by-step applications to equip professionals with the strategies needed to protect AI models effectively. To begin with, understanding the types of attacks that AI models are susceptible to is crucial. Adversarial attacks, such as evasion attacks, poisoning attacks, and extraction attacks, are among the most common. Evasion attacks occur when adversaries manipulate input data to deceive the model into making incorrect predictions. Poisoning attacks involve contaminating the training data, which can lead to faulty model predictions. Extraction attacks aim to steal the model's internal parameters, compromising intellectual property and potentially allowing malicious actors to replicate the model or uncover sensitive data. To defend against these attacks, several strategies can be implemented. One effective approach is adversarial training, which involves exposing the model to adversarial examples during the training phase. By doing so, the model learns to recognize and resist manipulative inputs. Adversarial training has been shown to improve model robustness significantly, although it can be computationally expensive. Another approach is to use robust optimization techniques that enhance the model's resilience to perturbations. This involves modifying the model's loss function to account for potential adversarial perturbations, thus ensuring that the model remains stable under attack. Techniques such as defensive distillation, which reduces the model's sensitivity to adversarial inputs by training it to output more stable probabilities, have also proven effective. In addition to these strategies, employing robust architecture designs can further enhance model security. Convolutional neural networks, for example, can be made more robust by incorporating dropout layers and batch normalization, which help mitigate overfitting and improve the model's generalization capabilities. Furthermore, ensembling models, which involves using multiple models to make predictions, can reduce the risk of adversarial attacks by making it more difficult for attackers to deceive all models simultaneously. Despite the effectiveness of these techniques, no single solution can completely secure an AI model. Therefore, a layered security approach is recommended. This involves implementing multiple security measures at different stages of the AI development lifecycle, from data collection and pre-processing to model deployment and monitoring. For instance, during data collection, data validation and sanitization processes should be in place to prevent poisoning attacks. During model deployment, secure channels and encryption can protect against model extraction attacks. Utilizing practical tools and frameworks can streamline the process of securing AI models. TensorFlow Privacy, an open-source library built on TensorFlow, offers tools for training machine learning models with strong privacy guarantees, effectively mitigating risks associated with data leakage during training. PySift, another open-source library, extends PyTorch and TensorFlow functionalities to include features for secure and private AI, such as federated learning and differential privacy. These tools enable developers to implement security measures without significant overhead, allowing them to focus on model performance and functionality. Real-world examples illustrate the effectiveness of these tools and strategies. For instance, Google's use of TensorFlow Privacy in its production environment has demonstrated its ability to maintain user privacy while delivering high-performance AI services. Similarly, the adoption of PySift by companies like OpenMind has shown that secure AI is not only feasible, but also scalable to large datasets and complex models. Continuous monitoring and assessment of AI models are also paramount in maintaining security. This involves using tools such as adversarial testing frameworks, which simulate attacks to evaluate the model's robustness. By identifying vulnerabilities, developers can implement necessary adjustments to enhance security. Additionally, anomaly detection systems can monitor model outputs to detect unusual patterns that may indicate an ongoing attack. Finally, fostering a culture of security awareness among AI practitioners is essential. This includes providing training on secure AI practices, encouraging collaboration among teams to share knowledge and best practices, and staying informed about the latest research and developments in AI security. By cultivating a proactive security mindset, organizations can better anticipate and respond to emerging threats. In conclusion, securing AI models against attacks requires a comprehensive approach that combines robust optimization techniques, architectural designs, practical tools, and continuous monitoring. By implementing a layered security strategy and utilizing tools such as TensorFlow Privacy and PySift, professionals can protect AI models from adversarial attacks and ensure data integrity and privacy. Real-world examples and case studies highlight the effectiveness of these strategies and underscore the importance of security awareness in the AI development lifecycle. As AI technologies continue to evolve, maintaining robust security measures will be crucial in safeguarding the integrity and trustworthiness of AI systems.